In this video, we're going to discuss how to use limits to compute instantaneous velocity. In our previous video, we discussed how we can approximate instantaneous velocity from a table, but in this video, we're going to look at how we can find the exact instantaneous velocity. And another word for instantaneous velocity is derivative. Derivative is also another word for slope. If you remember from the last video, we talked about finding slope of 2 points, or the slope of the secant line, and that's the average velocity. And then we also talked about the instantaneous velocity is represented graphically by the slope of the tangent line at one point. So say if we wanted the instantaneous velocity at point A in this graph, we'd be looking at the slope of this tangent line. And so we still want to set up a slope equation just like we do for any point. If you'll notice, the coordinates here, this is A, and so this is f of A. And they're saying that this point is A plus H. So this point B is a little distance away from A, a distance of H. And H just represents a very small horizontal distance. So H is going to be a very small number. And so the y value of B would be f of A plus H. And so if we were to set up slope, we would do f of A plus H minus f of A over A plus H minus A, y minus y over x minus x. And so we can simplify the bottom. We really just have f of A plus H on the top minus f of A all over H. And now this might be slightly different formula-wise looking. Normally we would have had an it would be f of B minus f of A in the slope. There would be a B here and a B here. And on the bottom, we would have had B minus A. So all we've done is change the B to A plus H. And so the idea is we don't want B to be far away from A. What we really want to do is we want to get B down the curve closer and closer and closer to point A, so that eventually the secant line becomes the tangent line. B gets so close to A that it's on top of A. And so the way we do that is we need to shrink this H distance. We need it to get smaller and smaller and smaller and eventually approach 0 so that A and B are 0 apart. And the way we do this is we add a limit in front of this formula. The limit is H approaches 0. And just vocabulary-wise, you may see this slope formula referred to as the difference quotient. I know your textbook uses this name sometimes. Difference because there's subtraction, quotient because there's division. Try to find instantaneous velocity using this formula is what they call the numerical method. And so in example 1, they give us s of t equals t squared at t equals 3. So we want to set up this equation. The numerical method is really just going to approximate this equation. So this is not an algebraic method. And so what we're going to do is we're going to pick values of h to plug into this equation. Like, you want to pick a very small value of h, typically maybe 0.1 or 0.01 or sometimes even 0.001. And we'll see what happens as h gets smaller and smaller. So using this formula, and really we can just use the difference quotient part of it, we can drop the limit when we're doing the numerical method. F of A plus H. So A is the value they give us, and then we're going to plug in the H value also. So we're going to have 3 plus 0.1 minus F of 3 all over an H value again of 0.1. So this is really just F of 3.1 minus F of 3 over 0.1. Well, our function is t squared. So we're just going to plug 3.1 and 3 into t squared. So we're going to have 3.1 squared minus 3 squared over 0.1. And now we can just type that in the calculator. (3.1 squared minus 3 squared over 0.1 is 6.1. And so we're going to repeat the same process, but we're going to use a smaller h value. So for this one, we're going to do f of 3 plus 0.01 minus f of 3 over 0.1. which is just f of 3.01 minus f of 3 over 0.01, excuse me. And so again, we're going to plug 3.01 squared minus 3 squared over 0.01 into the calculator. And that gives us 6.01. Okay, so let's do this again with 0.001. And what we hope to see is that as h gets smaller, that the values approach a certain number. And I think it'll be pretty clear in a minute here what that number is. Same thing, we're going to have 3.001 squared minus 3 squared over 0.001. And you may even be able to guess what this answer is going to be just by looking at the previous two answers. And this one is 6.001. So you can see that as h gets smaller, as h gets closer and closer to 0, these limit values get closer and closer to 6. So we would say that this is most likely equal to 6. And so in the next frame, we're going to look at how can we solve this algebraically. So when we do this algebraically, we're definitely going to use the limit in front of the difference quotient formula. So again, the t value that they're given, that's your a. You can either plug in a in the beginning, or you can just plug in t squared to begin with and plug the a in at the end. Either way, it doesn't matter. So I could set this up. This is the same thing as doing f of x plus h minus f of x over h. These formulas are really the same. You can have an x to represent any variable. You can have an a just to represent a number. So since I have a number, I'm going to use it. So I'm going to replace a with 3, but I'm going to leave h alone. I am not going to plug anything in for h in the algebraic method. Okay, so what this means here, when you have f of 3 plus h, it means go to the function, in this case the function, and wherever you see the variable, replace that with 3 plus h. So I'm going to write down, my function is t squared, but I need to replace t with 3 plus h, and I'm going to have to use parentheses, minus f of 3, so that just means plug 3 into the function, so minus 3 squared, all over h. And I really should keep my limit symbol in front of this. I should not drop the limit until the very end. So I'm going to have to FOIL, because I have 3 plus h on the top. So hopefully we're all familiar with FOIL. If not, you may want to Google a video on how to double distribute or FOIL. But 3 plus h would become 9 plus 6h plus h squared minus 9 on the end for 3 squared. And so then I can combine my like terms on the top. The 9s would cancel out. So I just have a 6h plus h squared over h. And then if you notice, everything in the numerator has a factor of h in it. So you want to factor that out. Use GCF. And then you'll notice that the h on top will cancel with the h on the bottom, and that is always going to be your goal. You want that h on the bottom to cancel out so that you can plug in 0 for your limit value. Until the h cancels out, you cannot plug it in. And so you're left with the limit as h approaches 0 of 6 plus h, and you just plug in 0 for h. So the answer is 6, which matches what we found in part A. So at this point, I want you to pause the video and try the u-try here. Find the instantaneous velocity for s of t equals 3t squared at t equals 2, both numerically and algebraically. So pause the video, and when you're done, start the video back, and I will give you the answers. Okay, so for this you should have gotten an answer of 12. If you did not get that, bring your work to class and we will discuss this. I also want to look at an example where you have a fraction for a function because the algebraic method involves a little bit more work. We're still using the same formula. This time they did not give me a point value, so I'm going to use x in the equation instead of a. So I'm going to use f of x plus h minus f of x over h. This is the same formula. It doesn't matter if you call it x or if you call it a. So again, this says go to the function and replace the variable with x plus h. So the first thing I'm going to do is write this function 1 over, but instead of just having x, I'm going to write x plus h plus 2 minus f of x, which is the original function, all over h. So this is a compound fraction. I don't like having fractions over fractions. So since h is in the bottom, you can actually pull that out as a separate fraction as 1 over h times 1 over x plus h plus 2 minus 1 over x plus 2. It just looks a little neater. Okay, so we have a fraction subtracting a fraction. We need a common denominator. So look at your two denominators. Each one of those needs to be in the common denominator. So our common denominator is going to be x plus h plus 2 times x plus 2. So the first fraction needs to have top and bottom multiplied by x plus 2. So 1 times x plus 2 is just x plus 2. And then we have subtraction, so we're going to bring down our subtraction. And the second fraction needs to be multiplied by x plus h plus 2. But we're subtracting, so we're going to put parentheses around this because the entire thing must be subtracted. Okay, so we're going to clean it up by distributing, or by combining our like terms. We do have to distribute the minus sign. So this is really x minus x, and this is 2 minus 2, so they cancel out, and we're just left with a negative h on the top. Don't worry about distributing out the bottom. You can leave it alone. You don't need to multiply that out. It's a lot of extra work, and it doesn't really get you anything extra. So at this point, you can see that the h on this top of this fraction will cancel out with the h on the bottom, which again is always our goal, to get the h's to cancel out. So we're left with the limit as h approaches 0 of negative 1 over x plus h plus 2 times x plus 2. And so now, because we canceled out the h in the bottom, we can just plug in h for 0 for any remaining h's. So we're left with negative 1 over x plus 2 times x plus 2, which can also be written as negative 1 over x plus 2 squared. And then, if they gave us a function value, like what is the derivative at x equals negative 1, if we haven't discussed this already, the notation for derivative is f apostrophe x, but we actually in math world pronounce that f prime of x. So we want the derivative at negative 1, and so we're just going to plug negative 1 into that function we just found. Which gives me negative 1 over 1 squared, which is just negative 1 over 1, which gives me negative 1. Okay, again, the next example is a you try. So again, I want you to pause the video here, try both examples, and then when you're finished, unpause and the answers will appear. We are not giving you work, we are just giving you answers so you can check yourself. If you have questions, make sure you bring them to class or post them on Edmodo to ask. So for part A, the derivative is negative 1 over x minus 1 squared. And for part B, you should have gotten that the derivative at 4 is negative 1/9. Again, if you did not get those, please be sure to bring your questions to class.